So this first session then, as part of all the lectures that I'm going to do, not every time, but a lot of the times, we're going to start off with little drills. You could call them a test, but I try and avoid the word test. Nothing to do with the assessment of this course. That's just down to the assignments. But to see how you're progressing, so you can see how you're progressing, and at the end of when you've done them, I want the marks, so I can keep a record of how you're progressing. We're going to do drills. Most weeks we will, not every week, but most weeks. Tend to tail off towards the end because we're focusing on assignments, but certainly at the start. So each week you're going to start off with a little drill. So I'm going to want you to have a piece of paper and put your name on the top so you can hand it in. So scrap piece of paper, the one that you don't mind losing, and put your name on the top, please, if you can do that. That'll probably be enough. That'll be fine, that scrap piece of paper. Yeah, that's fine. The questions, because of what I've been saying before, there's no need to jot down the questions because they're on these slides. So if you ever want to go back and see what the questions were and have another look at it, then you can always go back to that lecture. So all I want you to do is just jot down the answer, please, okay, to these questions that come along. No. Sometimes you will need a calculator, and I'll let you know, but generally, a mental arithmetic type questions. So, of course, no, if you can't do it, just leave it blank, and then I know you can't do it. Don't be tempted to copy it off your neighbour, okay? That doesn't help. So number one, drill, this is drill number one, question number one. Just jot down the answer to that, 10% of 48 metres. Number two, 3/4 of £8.20. Number three, algebra is going to be raising its head very soon in this course. It's an essential thing, you know, to an engineer to be able to manipulate algebraically. And so, x is this unknown. 2x plus 3x, what's that equal to? Number four, 2 times 3x, which might be written like that, or like that, or like that. All of those mean 2 times 3x. 2 times 3x, a little dot sometimes used, or a bracket. But what's the answer? 2 times 3x. Number five, not what's a third of 48, that's not the answer to this question. A third of 48 is the same as 48 divided by what? What's the missing number there? Number six, formula. You'll be using formulae a lot. There's possibly a familiar formula, and you're given some values, I and R, find V. Yeah, 12 amps, I equals 12 amps, R equals 24 ohms. What's V? Number seven, fractions. They come up in algebra, and so you need to be sort of happy manipulating fractions. If that's something that you struggle with when you try and do it and combine that with algebra, you can see that you're going to get yourself a whole heap of trouble. So Familiarity with fractions is important. A half plus 3/4, what's that? Number 8, estimation is a useful skill to an engineer. Estimate the mass of a small car like a Mini. I'll leave you to decide on the unit. Write down what you think it would be. Your best guess.
Are we talking original Mini or?
Good question. You decide, and then you can let me know which one you think, which one you're referring to. Number 9. 3 of those give the same answer, mean the same thing. One of them is different. Which is the odd one out? And number 10, because they always come in tens, don't they, these things? Actually, it's out of 9. And what you to do is to tell me how many you think you got right. Confidence thing. Are you feeling confident? Okay, so this is a self-mark exercise, so I'm not going to take these in and mark them, but I would like to take them in and have a look at how you got on. So if you want to scribble on these things, then at the end, once I've taken a note of the results, I can give them back to you. If you want to keep them, that's fine, but just indicate as you're going along whether you got it right or wrong, and then I want a mark out of 9 at the end, if you could put that on there so I can make a note of it. So picking it on people at random, and we're all in this together, so you know. Okay, so Sam Hopwood, where are you? Hello, Sam. Answer to number 1. 4.8 meters. Excellent. How did you arrive at that, Sam?
Just move the decimal place the other side of the 8 inches in between them.
Okay, right. So before we start, where's the decimal point? Always on the far right-hand side. And then you just shifted it one place to the left, which is exactly what I would have done here. Why is that the case? Why does finding 10% mean you move the point back one place? Anyone? Because you're dividing by 10. Right, 10% means divide by 10. Why is it divide by 10? What's 10%? 10 over 100. And 10 over 100 is 1/10. And 1/10 means to find 1/10 of something, you divide by 10. So to find 10%, you divide by 10. How do you divide by 10? You shift the point back one place, because it's a decimal system, so it goes in tens. So therefore, you're just shifting everything actually one place to the right, because you're making it 10 times smaller. So the point goes one place to the left. Okay? Everybody happy with that? Of course, finding 10% means you can easily find 20%, 5%, doesn't it? And so on, okay? Three-quarters of 8 found 20. Ross? Where's Ross? Ross. Oh, didn't you? Okay. Anyone else? Yep. £6.15. And how did you do it?
I don't know, it's hard to explain. I just divided it. I put it into quarters.
Good. You want to find the quarter. How do you find the quarter?
Half and half of it.
Half and half again. Is that what you're saying? Yep. To find a quarter of something, half and half again. Don't try and do 4s into £8.20. It will work. 4s into £8.20. 4s into 8 goes 2. 4s into 2 won't go. 4s into 20 go 5. So that's £2.05. But in my head, half of £6.50. Sorry, half of £8.20 is £4.10. Half of £4.10, £2.05. Quicker, isn't it? Okay. So why do you find a quarter? So that once you've got a quarter, which is £2, right? Because that means 3 of them. So fractions. What is this fraction here? That's what we're dividing it up into, quarters, which you've done. And then once we've got 1 quarter, that top number tells me I need 3 of them. 3 quarters. £6.15. Okay? Elise, 2x plus 3x. You put 5x. What does 2x mean to you? 2 lots of x. Exactly right, that's what it means. So I could write it like that, couldn't I? So therefore I could write that like that. So if I add them together, I've got 1, 2, 3, 4, 5 lots of x. Correct. That's right. Okay. What is x? What does x represent? What does x or a or b or any other letter, what does x represent in algebra? Yeah. Anything. Give me an example of what it might represent. Pardon? 4, right. So not anything, any number, yeah. Not anything, not a table. X doesn't represent the object, does it? It represents the number, and that's a key difference. X represents a number. We just don't know what that number is. Two times 3x. Daniel. What do you reckon?
I said 6x, but it's not right.
Why do you say it's not right? What does 3x look like? What's 3x? 3 lots of x. 2 times that is another 3 lots of x. So how many x have you got altogether? So you're right, 6x. Yeah, good. Okay. One of these we wouldn't use to represent 2 times 3x. Which one? The top one, because yeah, they may well be confused. So we don't use 2 times 3x in algebra. So we either leave it blank or put a little dot in there to represent the multiplier. You will sometimes see that, although that can be confused with a decimal point. So that really is the most unambiguous way to do it, to write 2 brackets 3x. Okay. Number 5, Chris Clark. Where are you, Chris?
3.
Yes, 3. A third of 48 is the same as 48 divided by 3. How do I find a third of something? I divide it by 3. Okay? Obvious? Is this equally obvious? That's that same statement written algebraically. A third of x is equivalent to, note that, x divided by 3. Is this equally obvious? X plus 4 squared over 5 is equivalent to what would I write? No, that's supposed to be a 4. Look at what we've just done here. Instead of writing it like that, I could write it as what could I put in front? A fifth. A fifth. Is that equally obvious? Because that's when this starts to get a bit more tricky, okay? They are equivalent. And you might say, so what? Well, if you're in the middle of an expression and you're trying to compare one thing with another, you can miss that actually dividing the whole lot by 5 is the same as finding a fifth of it. They are the same thing. Because of this. Because of this. Yeah? Happy? Happy? Not happy? Yeah. Yeah, right. Next one, number 6. Anybody recognise that formula? It's called Ohm's Law, yeah. So V is the subject of this formula because that's what it's set up to read, to find the voltage. And to find the voltage, what have I got to do? With the I and the R. Times them together. So in other words, because remember, we try and avoid this multiplication symbol in algebra. No symbol between letters means by default multiply. Okay? So I times R. So 12 times 24. 12 times 24 in your head, 288 volts. It would give you an ohm amp, and another name for an ohm amp is a volt. So we don't tend to talk about ohm amps, but that is the same thing. We talk about the volt. That's a good general point actually you just made there. Sorry, what's your name? Cameron, yeah. To do with units, the units on the left-hand side of this formula and the right-hand side must be equivalent. They must be the same. So the amp ohm, or the ohm amp, must be equivalent to volt. And that works for any formula. Number 7. Seem to avoid anybody from the back row at the moment. So back in the middle in the black t-shirt. You are Jack. Jack. 1/2 plus 3/4. 1 whole and a quarter. I agree. Yeah. Can you tell me how you got that? Yeah. But how? Do you sort of what was going on in your head? Right. Okay. Well, that's good. Anyone else like to? What we're doing here? Yeah. Yeah, that's the sort of thing. So what would you do? So you get 2/4. A half is equivalent to 2/4. That's the sort of thing that probably you automatically just knew, didn't you, Jack? Yep. So 2/4 plus another 3/4. Now these are the same. I can add them together. 2 plus 3 gives 5/4. Is 5/4 equivalent to 1 1/4? Yeah. 4/4 is a whole 1 plus 1 other 1 4 and 1 1/4. Okay. The key to these things when you're adding fractions, and this applies to algebra, I can add algebraic fractions so long as the denominator, which is the name for this bottom bit, is the same. Yeah, so the key then is to make them the same algebraically. And we'll be doing that sort of thing. That's why it's important to understand these fractions. So what do you reckon then, Cameron? Which one are you going for, the old one or the new one? The original?
Let's say 800 kilograms.
800 kilograms. That's pretty spot on, actually. Well done. It's around 850, 900, I think. I looked it up on the internet for the old type.
Yeah.
What about the new one? Would you say more or less? Yeah, well, a bit less. Just about 1.2 tons, something like that. But heavier. So the new one, around about 1.2 tons. 1,200 kilograms, so good. So, I mean, the idea of estimation, if you get near it, give yourself a mark, because it's not exact, okay? But if you put 8 tons or 8,000 kilograms, don't give yourself a mark. If you put 80 kilograms, you know, if you're miles out,
How many miles are there?
well, what did you say? Pardon? A ton, that's pretty good. Yeah, ton's good.
The old 850s already.
Yeah. Oh, yeah. What engineers do is come up with what's called an order of magnitude estimate, which means a factor of 10. 10, 100, 1,000 and so on. What's the mass of a Mini? Round about 1,000 kilograms. Not 100, not 10,000, 1,000. Okay. Number 9, last one. That back in the corner. You are? Sorry. D, that one. Unfortunately not, no. Yeah. C, no. B. B. 2/3. We've already talked about this, look. 2 divided by 3 is the same as 2 times a third. 2 divided by 3 is the same as this. If you didn't know, 2 over 3 means 2 divided by 3. So they're the same. And 2 divided by 3 is the same as 2 times a third, which we've been talking about. So they're the same. What's wrong with this then? What should it be? Yeah, it's 3. How many 3's are there in 2? Not how many 2's are there in 3. 2/3 is less than the whole one. So if I want to work out what that is as a decimal, I divide the bottom into the top. The bottom into the top, not the top into the bottom. Beware of that. If I wanted to know what 2/3 was as a calculator, I would do 2 divided by 3 as it's written there. But if I want to do it on paper, I'd do it the other way. Okay, add up what you got, give yourself a score out of 9.
You get a score for getting your estimate right. I'll get it right if I get a score for getting my estimate right.
Oh, see, right, yeah, no, that's that you can't.
Yeah,
That's a bit. Well,
I got
it's out of 9. It's out of 9, so your estimate.
Pretty close.
Yeah, yeah. Okay.